So how do you learn LALR1 parsing, right? I just want to write my own parser generator. It's easy, right? You just crack open a.k.a. Sethi Ullmans Dragon Book. You flip over to the last section of section 4.7. You just read it and then you translate it into code, right? Yeah. So let's talk about what it would really take to do that. So it's kind of jump ahead to 4.7 and just try to do it. So you're going to start off with, learning about the efficient construction of LALR1 parsers. That's really what we're after. We don't want inefficient LALR1 parser. But then, of course, in order to do that, the efficient construction of LALR1 parser relies on sort of the full LR1 construction, which is, of course, inefficient and space consuming. But you kind of have to understand that you have to understand what's inefficient about it in order to learn what is efficient about it. In order to know all that, then you need to know a whole bunch of stuff, right? You've got to understand the concept of LR1 items. Then in order to understand that, you've got to know what the LR1 closure function does. And you've got to know what the LR1 go-to function does. Okay, and let's see, then you also need to understand the concept of like LR1 item merging and compaction. Okay. We need to understand various terminology like what is an LR1 item core. Because you need to understand what a core is in order to understand how to do merging and compaction. You need to know what a kernel item is. You need to know the concept of look-ahead sets. Then we need to know the concept of, well, this whole thing I've been describing is a canonical LALR1 construction, another word for it, or canonical LR1 parser table. So you need to understand the concept of the canonical LR1 parsing table. Okay, and then some other terms they throw in some of their narratives that you need to understand. What is a valid item? You need to understand the concept of a viable prefix. And in order to understand viable prefix, they at the same time they're talking about that, they talk about this concept of a right sentential form. Right sentential form. Okay, and then so that's LR1, which leads to LALR1. Sort of preceding that is I'm kind of working backwards here from 4.7 backwards into the book. You get into SLR, or sometimes called SLR1 parsing, which is a more limited form of LR parsing. It's not as powerful as the full LR1 parsing. So then we also need to understand, the SLR1 parsing table. And in order to understand the SLR1 parsing table, in order to be able to construct the SLR1 parsing table, we need to know the concept of the first and follow functions. So you need to go learn what those are and how to write those. Functions. Okay, and then you need to know the concept of the SLR, similar to the LR1 closure and go to. We need the SLR1 closure and go to, which don't incorporate as much information about the look ahead set as the LALR1 parsing. But you kind of need to know that because it leads into the LR1 closure and go to. So you need to understand that as a prelude to that. In the course of all of their narrations, they talk about this concept of a derivation. And in order to understand derivations, you need to know this terminology or this notation. You have a double right arrow and a double right arrow with a plus on it, which means one or more steps. Double right arrow. So derives in one step, explicitly derives in one step, or one or more steps is the plus. Star means 0 or more steps, and then you can put a for any of these, you can put either an LM underneath of it, which means leftmost, and then right, RM means rightmost. So they start to use this terminology and notation a lot in order to describe kind of why it works. Like they're describing a concept and then they're trying to describe some of the theory behind like why it works. Like, well, if this derives this and this and this, then we know that there must be a look ahead item such that this, we can go from this set to that set, etc. And then this whole thing is based on the concept, which they, again, kind of working backwards here, the concept of SLR sets of items construction. Sets of items construction. Okay, and the sets of items, the narration around the sets of items talks about deterministic finite automaton and non-deterministic finite automaton, DFAs and NFAs, and they briefly mention in that discussion about how, well, this technique is really could be thought of as the subset construction. So they introduce this concept of a subset construction. Which is basically a technique for converting an NFA, a non-deterministic finite automaton, into a deterministic finite automaton, which they actually talk about all of this in chapter 3, which isn't about parsing at all. It's about the lexical analysis that kind of precedes the parsing, but that's where they introduce NFAs and DFAs in this subset construction. Of course, all of this assumes that you understand, grammars in general, the concept of grammars, and specifically that you understand BNF notation, Backus-Naur form BNF notation. And the concept of a production. E produces E plus T. Okay, and then in order to make sense of any of this, you're going to need to understand the concept of the LR parsing algorithm itself in order to understand what we're trying to accomplish by building up this LALR1 parsing table. We need to know how that feeds into the general LR parsing algorithm, which involves states and the stack, the parsing stack. Of course, you have the input string. That's what you're parsing. That's the whole point of all this, is to make sense of your input string. And then building up the parsing table, which is basically, when you're building the parsing table, you're building up a table that's got actions and go-tos in them. And that all feeds into the general concept of shift-reduce parsing, which all of these examples at LALR, LR, and SLR are all examples of shift-reduce parsing. So that's about it. It's easy. You just gotta understand all this stuff. Oh, and then the last, or the first and foremost, the absolute most important thing you need to understand is the notation. If you don't understand the notation, you're not going to get very far with Dragon Book, because you're going to be lost really, really quickly. So it's very, very important to take the time to learn and understand the notation, which I know is kind of boring. I mean, when I first started reading the book, I just wanted to jump directly to section 4.7 and learn how to do an LALR1 parser and be done. But I had to sort of backtrack through all of this stuff, and I finally begrudgingly had to say, okay, I need to learn the notation, because I can't understand a lick of what they're talking about without understanding the notation. I mean, the whole entire book just looks like a jumbled up bunch of gibberish if you don't understand the notation. So this is absolutely critical. So start there, and then I'm gonna work my way through some of these prerequisites and lead up to this. That's the plan. Good luck.